collective team exercise, you can really see the difference in project management. Moving on to the sprint backlog. The backlog is prioritised and work is committed to for this particular sprint, which becomes the sprint backlog. The team will break down the backlog into user stories or smaller tasks or sub-stories, and then will allocate the work to themselves or other team members. Moving on to the Scrum meetings. Once the sprint backlog has been committed to, Scrum meetings will take place at the same time every day in the same location. And these meetings are ideally meant to be very quick, focusing on the salient facts that are pertinent for this release only. The objective of the Scrum is for each team member to answer 3 questions. What I have accomplished since my previous Scrum, what I will be working on next, and what impediments are preventing me from accomplishing my goals. These meetings are key to ensure that the team can achieve their goal or change quickly if any work is reprioritised. We move on to the final acceptance meeting. Towards the end of a sprint, typically, a final acceptance meeting will take place. In this meeting, the team will present what they have delivered in the sprint, usually to the business. And then moving on to the retrospective, which is an end of iteration meeting. The team will get together to discuss 3 things from the previous sprint. What we should start doing for the sprint, what the team should stop doing for the next sprint, what previous sprint was successful and should be carried over. And the team members are generally required to mention at least one of these in the retrospective. So, earlier I spoke about some of the key issues that Microsoft have looked at and addressing with Visual Studio 2010. So, these issues are generally different things stored in different locations and how we can bring the business closer to development, closer to testing. And we've seen that using Visual Studio 2010 with TFS and the other clients available will bring that closer. So with manual testing can sometimes be very tedious. So Microsoft wants to make manual testing less tedious by making it simpler, faster, quicker for manual testers to run their tests. The typical old story of you file a bug and you hand it over to the developer, and the developer says, oh well, the defect doesn't appear on my box, it's fine. So eventually the defect is probably closed, and then it finds its way into the product where it could potentially arise again. And finally, you've just finished your testing and the developer says, oh, I've made 1 line change in the code, can we retest again? So it's impossible to determine where the possible defect would arise with this small change, so retesting is required once again. Moving on to testing capabilities found in Visual Studio. Some of these I'm going to talk about here briefly, and others I'm going to look at in depth a bit later. So we see that there's web performance testing, or web testing as it's been branded for this release of Visual Studio, which allows testers to record interactions with site and playback, and can make tests data-driven or wrap up the test in load testing. It's not so much concerned with the testing of the front end of a website, but more to do with non-functional requirements of the application. For example, a test might be set up to determine the amount of web pages served per unit of time, or resource uses, such as processor and memory utilization. Load testing. Load testing can be run to ascertain how well the application under test responds to various levels of usage. Load tests can be made up of both unit tests and web performance tests. A load test is designed to simulate many users accessing a service simultaneously and can emulate differing types of users and a variety of network types. So we could be testing a dial-up network connection if we really wanted to. Moving on to unit testing, this is more of a developer task. It's writing code so there's better support for TDD. Typically white box testing, it's a task to build and run the tests pre-deployment to ensure that no changes made to the source code have broken the existing functionality. The data collectors level here that spreads across the generalist and specialist, this level allows testers to collect all the info they want when running tests, take this information and pass it back to developers to allow them to fix that problem. The virtual lab management is something that we're going to be looking at a little bit later. Test case management is something else we'll be looking at. It's a UI for testers to develop their test cases. Manual test run is also something we'll be looking at a bit later. And the coded UI support, which is test automation to automate exactly what we like, web pages, other applications, link between manual tests and auto tests. So moving on to the agenda here, I'm going to be introducing Test Manager now, which is the client that testers will be using. So broadly speaking, Microsoft Test Manager 2010 could be split into two separate components. The Lab Center, which is used to create and manage virtual environments using testing, and Testing Center, which we'll use to create requirements, link these requirements to test plans and test cases, create and raise bugs, run tests using Test Runner, typically the type of things that you would expect a manual functional tester to be running. So I'm going to focus on this first and give a brief demo on running and recording a manual test and playing back using the Test Runner software. This playback feature is something that interests me greatly as a manual tester who's had to work on projects where testing and retesting is required. So Test Center. Test Center is a separate client from Visual Studio. You don't even have to have Visual Studio open or even installed on the particular machine. This is the UI that I can use to create test plans, test cases, test suites, linked requirements, etc., etc. Test Center is built on three broad tasks, and these are separated functionally as tabs in the Test Center. There's the plan, decide which test you want to run in the test plan and what the key configurations are. Test, run your test from your plan on each of the configurations selected and record the results. And track, measure your testing progress and the quality of the software that you are testing. So, moving on now to the first demo. This is a recording of a particular create and run a test case, which I'm going to open up here. Okay. So I'm going to move on to the environment which the test is running on here. So I need to open up first Microsoft Test Manager. So I'm going to go to Start, All Programs, Microsoft Visual Studio 2010, and Microsoft Test Manager. So Microsoft Test Manager is the client in which we'll be connecting to the TFS in order to see the project work items that we have stored there. I'm going to go back to the beginning so that we can see when you first log on what the user is presented to. So here we can see the Add Team Foundation server, which is where all the work items are going to be stored. It's a particular URL, but I'm not going to be doing that now, as I've already connected to a particular TFS. You can see TFS server, the default collection. Tailspin Toys is the project that I'm going to be working on. I'm going to select iteration 2, as this is where the test that will be running is stored. So this is the testing center here. Across the top there you can see that there's the three tabs, the plan, test and track. On the left-hand side, there's the Iteration 2 test suite, and underneath there we can see the requirements that have been added by the tester. The end-to-end test is where the particular test that I want to run is stored, which is check receipt number is present. So I'm going to open that up, and we're going to take a look at the information stored within this test. So across the top there you can see that there's the title, check receipt number is present. This is the name of this, becomes the name of the test case, and then underneath there we can see the status of the test, who it's assigned to, the state of the test, whether it's ready or closed or in design, so we know whether it needs to be run or not. We can assign a priority to a test from high to low, and then there's the automation status, whether we plan to automate it or not. And then there's the classification area that's already been filled in. Moving down to the central section is the test steps. On the left-hand side there's the action, which is what we would expect the tester to do in the application under test. And on the right-hand side there's the expected result, so the direct consequence of that particular action being run. Moving down to step 6 there, we can see that some of the words there have got the @ symbols next to them. This parameterizes them, which means that we